Assalamu alaikum everyone. Here I'm your teacher, Miss R Square. In this class, we will learn about discrete mathematics and some background knowledge that would help us in this course. Before defining discrete mathematics, you have to learn two basic concepts. The first one is continuous data, and the second one is discrete data. Continuous data. What is continuous data? Continuous data means the data which is continuous in nature, okay? And discrete data which is discrete in nature. Now, to explain more, continuous data, the data which is without jumps or gaps, means it is continuous like this. There are no jumps and gaps between the continuous data. Okay, for example, real line. Real line starts from 0, 1, 2 up to positive infinity, and -1, -2 up to negative infinity. Okay, let's suppose we pick up 2 points from the real line, 0 and 1. There are infinite numbers between 0 and 1. Alright, so this kind of data is continuous data because there are no jumps between 0 and 1. We have infinite numbers between 0 and 1, so it is continuous data, not discrete data. Okay, on the other hand, we have discrete data which is discrete in nature. So now we will see that discrete in nature, what does it mean? Okay, discrete in nature means having jumps and gaps. Okay, the data which has jumps and gaps is called discrete data. Okay, for example, there are 2 persons in a room. Okay, or you can say there are 2 kids in a room. Okay, so where is discrete data? As we are talking that there are 2 kids in a room. In this data, there are 2 kids in the room. Where is discrete data? So here is discrete data, 2. You can't say that 1.9 kids are in the room. You can only say like this, 2 kids, 3 kids, 4 kids, up to so on. Okay, so now let's move to the definition of discrete mathematics. It is a study of mathematical structures that are fundamentally discrete rather than continuous. So now there is no difficult thing for us to understand that what is discrete mathematics. Okay, because we have learned that what is discrete data out there. Discrete data is now simply linked with the mathematical structures that are fundamentally discrete rather than continuous. those structures which are discrete, not continuous. Continuous not like this without jumps and gaps. We have to be like jumps and gaps. Okay, so in this subject we will study the mathematical structures that are discrete in nature rather than continuous. If we need to refer an example with the definition, we can refer as integers, set of integers or integers. Okay, integers are like plus minus 1, plus minus 2, plus minus 3 and up to so on. Alright, so this is the example of discrete data or discrete mathematics. Alright, so let's move to the next thing, which is disjoint and overlap. Okay, now we have to learn two concepts: overlapping and disjoint sets. Alright, I'm teaching you all these concepts because I want you to understand my next lectures easily. Due to this reason, I'm learning you all these things before doing to the stepping to the next difficult things out there. Disjoint sets. For example, you have two sets, A and B. And for this you have to find the intersection between these two sets. And if the intersection between A and B equals to phi, then the sets will be termed as disjoint sets. Okay. On the other hand, a set is said to be overlap, or two sets are said to be overlapping sets if their intersection does not equals to phi. What is phi? Phi means empty set. After taking intersection of these two sets, you would get empty set. In this case, you would get empty set, and in this case, you won't get empty set. I'm repeating this again. Two sets are said to be disjoint sets if their intersection is equals to phi, empty set. And two sets are said to be overlapping sets if their intersection does not equals to empty set. Now let's move to another concept, that is cardinality. Cardinality of a set. Okay. Cardinality of a set. What is cardinality of a set? For example, you have this set contain, for example, the elements 1, 2, 3, 4 and 5. Okay. So now we need to find the cardinality of A. What would be the cardinality of A? 1, 2, 3, 4, 5. So the cardinality of A would be equals to 5. So what you have got from this, that cardinality of a set is equals to number of elements that are present in the set. Alright, so what we got is cardinality of a set is equals to the number of elements that are present in the given set. So the cardinality of this example is 5 because the number of elements in this set are 5. So the last thing that we need to learn is why we are using discrete mathematics. Okay, so discrete mathematics is used for programming languages, software developments and algorithms. Especially to design an algorithm we need discrete mathematics. So these are the simple applications of discrete mathematics. So today's class is finished. Hope so you would learn the knowledge a lot from my video. So subscribe my channel, and if you have any question, comment below and ask me. I would let you to know what would be the answer of your queries. Allah Hafiz.